Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph linear inequalities when they are in standard form. And when graphing linear inequalities, it's just going to be like graphing linear equations. And so we're going to use the same process, knowing of using slope, converting them to slope-intercept form. You can also use the intercept method. Find the x and the y intercept by plugging in 0 in for x and for y, and then solving for the other one. But I don't really like it so much, that method for this. I think the easiest thing to do is just to know how to rewrite them in slope-intercept form and then plug them in. But maybe for the first problem, maybe I'll do that since it's not as much work. But for the rest of them, I think I'm just going to get you used to solving for in the slope-intercept form. So basically, if you remember, the slope-intercept form is, as an equation is y equals mx plus b, where m represents the slope, b represents the y-intercept. Remember, m is a ratio, where b is a point. The ratio rise over run, or change in y over change of x, where b is a coordinate point on the y-axis. All right, so the first thing we want to do is we want to make sure we can rewrite it. Now, I notice this is an equation that's an inequality. And basically, the difference is not going to be the same, except remember, inequalities, we're going to have a boundary line that's either going to be solid if it's a part of the solution, or dashed if it's not a part of the solution. And then we're also going to have to choose points that are below or above the line to determine if they are a part of the solution or not. So we're going to use test points for that. So if I wanted to solve for y here, you see I'm adding a 2x, because that's a positive 2x. So the first thing we're going to do is subtract a 2x on both sides. So I have y is less than negative 2x. I'm going to write the negative 2x in front of the positive 6. OK, so now you can see my y-intercept is at positive 6. So I go on the y-axis up 6. 1, 2, 3, 4, 5, 6. Then hopefully you notice that the slope here is a whole number, 2. So whenever you have a slope, you always want to rewrite it as a fraction. So I'm going to put it under 1. So now I have negative 2 over 1. Oops. 1, 2, 3, 4, 5, 6. So there's my y-intercept. So since the slope is negative 2 over 1, I'm going to go down 2 to the right 1. And you can just continue that if you'd like to. Down 2 over 1, down 2 over 1. Or you could flip the negative signs and go up 2 to the left 1. But that's going to be enough to determine my line. I went over how to determine test points if it's dashed or solid. So I'm just going to kind of move forward with this and notice that whenever you have less than or greater than, you're going to have a dashed boundary line. Let me do one more point. Down to the right 1. OK, so I'm going to connect these points here with a dashed line. OK, then the best thing to determine testing, it really doesn't take too much work. You can look at the inequality symbol as long as your y is on the left-hand side, which in all these examples it is. So however, you do want to be careful, because here, like an example like this, that's not always going to be the case. You're going to want to make sure you solve it for y and then test your point. But I think the best thing you can always do is choose a test point that's not on the line. And the best test point to always pick would be 0, 0, as long as it's not on the line. Plug 0 in for y and for x. And I have 0 is less than 6, which is true. Since my test point is true and it's below the line, that means all the points below the line are going to be true. OK? Yeah, I didn't run out of space. I'm just going to convert it to slope-intercept form. I have videos on how to do intercept form if you like that method. But I think once you get used to this, it's not too bad. So here, again, you have a y that you're solving for. Now, my y is negative, but now I'm adding a 3x. So I need to undo the adding. So I'm going to subtract a 3x on both sides. Now I have a negative y is less than or equal to negative 3x plus 1. OK? Now, to solve for y, all right, to make sure we solve for y, the main important thing that we need to do here is divide by a negative 1. But remember, in inequalities, whenever you multiply or divide by a negative 1, you have to make sure you flip the sign. So I'm going to divide by negative 1 here. And what I'm going to obtain is y is now, I'll write this in a different color, is now greater than or equal to. So negative 3x divided by negative 1 is a positive 3x. Positive 1 divided by negative 1 is a negative 1. So I have y is greater than or equal to 3x minus 1. Now let's go ahead and graph that line on our graph. So we have a y-intercept of negative 1. So I'm going to go down to negative 1. I have a slope as a whole number. So I'm going to rewrite that as positive 3 over 1. And then that's going to tell me to go rise 3, 1, 2, 3, and then to the right 1. Now I go ahead and look at my inequality symbol. That is a greater than or equal to. So it's going to be a part of the solution. So it's going to be solid. Okay. Then again, I want to go ahead and use my test points. So I'll just use 0, 0 again, and to test. Now, again, since I've solved for this for y, I know it's greater than or equal to. I can assume that I can now, through my examples, that I know that I'm going to be shading above. But let's just go ahead and use a test point just to prove that. 0 is greater than or equal to -1. That means that is true. That means all points above the line are true. OK, so now let's go and get into this one. Again, in this case, I have x plus 4y is greater than -12. So the first thing I need to do to solve for y, I have my y is being added by x and it's being multiplied by 4. The first thing I need to do, though, is undo addition and subtraction. So I'm going to subtract an x on both sides. Therefore, that's going to leave me with a 4y is greater than -x minus 12. Now I need to undo multiplying by 4. So I'm going to divide by 4 on both sides. And I have y is greater than. Now, it's very important. Remember, this is technically a -1 times x. And you got to divide this 4 into both of these terms. So what I'll have, and I'm going to keep that 1 there. I'm going to use that 1 because it's going to help me with the, you could leave that as -x divided by 4. But as far as graphing, you want to have your coefficient as a fraction. So I'm going to leave that 1 there. And I'm going to rewrite this as a -1/4 x. And then -12 divided by 4 is a -3. OK? So it's really important that I kept that 1 here so I can use my slope. Now I determine the y-intercept, which is -3. 1, 2, 3. And then the slope here is -1/4. Remember, that could be -1/4. Or it could be 1 over -4. So let's just do both to make sure they're going to lie on the same line. I could go down 1 to the right 4. 1, 2, 3, 4. Or I could go up 1 to the left 4. 1, 2, 3, 4. And you can see that they're going to create in the line. Now, I look at my inequality symbol, and it's greater than. So therefore, this is going to be represent a dashed line, meaning all points on the line are not a part of the solution. Then the last thing I want to do is go ahead and use my test point. However, I can also see that since y is solved on the left-hand side, I know that's greater than. That means all y values above this line are going to be true. And you can always do your test point like I did before, but I'll try to make this video go by a little bit quicker. So you're going to shade above the line. All right, in the last example here, again, we're just doing the same order over and over and over again. We got to solve for y. So to undo that, first thing we're going to do is undo adding 2x. Therefore, I'm left with a 5y is less than or equal to a -2x minus 10. Again, we write the -2x in front of the 10 so we can make sure it's in slope-intercept form. Then I divide by 5. And I have y is less than or equal to. Again, this is a negative, so I'm going to write the negative in front. A -2/5 x. -10 divided by 5 is a -2. So now let's go down to -2. OK. I'm going down to -2. And then the slope, again, you could go up and to the left or down and to the right. I'm just going to do 1 here because I already showed that it doesn't matter. So let's do up to left 5. 1, 2, 3, 4, 5. OK. Now that's less than or equal to, so it's going to be a solid line. And then you can see that my y is less than or equal to, whereas greater than or equal to, I knew I had to shade above the line. Since it's less than or equal to, I'm going to have to shade below the line. And again, if you don't really understand that, the main important thing is to have your y isolated, solved on the left-hand side. And then you can determine wherever the arrow shows it's either going to be a below or above. But if it's, again, if it doesn't make sense, just use your test points. Just plug in a point that's on the line and test it. If it's true, shade all the points that are next to that line. So there you go, ladies and gentlemen. That is how you graph an inequality when given in standard form. Thanks.